Hello everyone, in this tutorial video we are going to study about the last type of induced infiltration method, which is well, which is including tube well. So in this case we will be studying about various types of the wells. So basically we classify in this case two types of well. One is open well, another is the tube well. So both of these wells are which are basically made by using by excavating the earth, and that helps in bringing the water to the surface, whatever the water that is present below the surface. So both of them help. So in the case of the open well, that is also known as dug well, which in this case there are larger possibility of contamination of the water in comparison to the these tube wells. But these open wells or dug wells, these are simple types of well. So if you want to just construct certain types of well, you just need to just go through the excavation work. If let us suppose if this is the ground level, then you just simply need to just excavate the land depending upon what is the exact water table at that place, you will get the water in this type of dug well or open well. So there are certain specifications which are given in this case, which includes that, and which says that in this case you will obtain a lower discharge of about 1 to 5 liters per second, and the diameter of also these type of wells vary from 2 to 9 meter, and its depth is also generally 20 meter for such type of open well. So these are some of its specification, and it also says that the thickness of its wall also varies from 0.45 to 0.75 meter, and that also depends upon the depth of the this well. So now just if you just go through one diagram to just understand quickly. So this is a case of one type of the hand pump. Okay, so that is being constructed in a dug well. What you have done, we had a simple dug well, and we has just put a hand pump over there, which helps in the just taking out this water from this dug well. Okay, so instead of having a pulley type of system, we have just placed a hand pump, and we have just covered the well by a masonry work, and we have this underground shallow depth, and from there we are just taking out water through this hand pump. So this is again one method by which we can just take out water from such type of wells. So this yield of certain type of open well, that is limited because they such type of well can be excavated only to a very limited depth. So we don't go for very far down, it is very limited to a limited depth. So obviously if it is limited to very shallow depth, then its storage will also be limited. So in order to enhance such type of the storage in this type of well, they are mainly preferred in those areas where the water table is quite high, so that if the walls are permeable, then the water can come inside of it, and this can enhance its water capacity or its volume of the water that is stored in it. And one of them again, the recent method that have been used in order to improve this kind of the extraction of water from this well is to construct open well, and which is having a dia of 8 to 10 centimeter borehole, and that is being placed in it, so that this type of boreholes when goes inside of it, it just helps in taking out or brings up more water inside the wells, and this just increase the water level in this, and when the water gets pumped out, we will have sufficient amount of water for the use. So depending upon mainly the depth of at which these open wells are being excavated, these are mainly classified as shallow well or deep well. Okay, so let us consider that these are the two types of well. This is shallow well, this is a deep well, and this is having a mortar layer, or you can see impervious layer between this pervious and this pervious layer. So in the case of this shallow well, what we actually do is that we try to just take out water from this pervious layer, and these walls or this pervious layer don't go the top of this mortar layer. Okay, but in the case of the deep water, when we are excavating the water, we actually excavate and goes down below this mortar layer, and then we just dig out water from the this pervious layer that is stored below of this mortar layer. So if we compare the water quality of both of these well, then you will find that the water in this shallow well is more contaminated in comparison to the deep well, because we are just taking out water from very deep below of this mortar layer. So obviously its water quality will be far more better in comparison to the shallow well. And one more statement is that you should not just conclude that if it is a shallow well, then its height will always be lesser in comparison to the deep well. It's not like that. There are certain cases in which the shallow well depths are quite large in comparison to the deep well. So it really depends upon when these type of well encounters this impervious layer. So in case if encounters at a very greater depth, so that will be again a shallow depth shallow well. But if we are constructing a deep well, encounters this mortar layer at a very beginning stage, and then it goes to the beyond this mortar layer to this pervious layer, then that will be a deep layer. So depending upon when it just reaches the water source, so just we classify both of these wells as shallow and deep wells. So as I have explained, all these are quite written over here. Okay, so next we will move through the cavity formation in this open well. So as you can see here that this is one of the open well. Okay, so there might be we have gone through the what is cone of depression, radius of influence. We know all of these things from our previous lecture. What are both of these things basically trying to depict? So the thing which we are focusing in this cavity formation in this open well is that how this cavity forms at the bottom of this open well. So what actually happens that when you just don't take out water from this type of open well for a longer duration of time, and suddenly if you just take out the water from these type of open well, then there will be a depression in the water level. Okay, there will be depression, the water level will goes down, and correspondingly there will be a certain cone of depression. So this vertical distance is known as depression head at it, as it is written here. So what are the conditions of the cavity formation, that we also known as a piping effect? So what actually happens is that the velocity of the percolating water into this well, that truly depends upon what is this depression head. Okay, so if the depression head are quite large, then the water that will be percolating inside of it will have a greater velocity. Okay, so if the more amount of water is withdrawn from this well, more depression head will be there, and therefore it will increase the depression head, and there will be higher the velocity, and that higher the velocity of the water in the vicinity of this well. And when the velocity of the well of the water is high at its velocity, then it is more possible that the flow velocity may exceed the critical velocity of the water, and when this happens, the soil particles are lifted up. Whatever the soil particles are there, they will be lifted up, and a cavity formation will take place. Okay, but as soon as the process continues on, the velocity decreases and this process gets stopped. But for that period of time, we have a cavity or hollow formation. So that method is known as, or that process is the cavity formation. Moreover, if you want to construct such type of open wells, we have basically three types of such type of open wells. First is when its impervious lining of these wells are impervious, that we are mainly constructed by using masonry lines with proper mortar layer. Next, it will be a pervious lining where we will using the dry brick or stone masonry, but it won't be a impervious layer. And the last one is the kacha well, where it is most economical type of the well. So if you are constructing the well with the impervious layer, whatever the edges of the wells are there, that has been constructed by using stone or bricks masonry, and we mix them with the mortar layer, so that whatever the water from the side of the wells, they don't enter through it. So that's why it is being said that these are the wells with an impervious lining. But for the pervious layer, we don't provide the mortar or the binding material which makes the water recharge capacity of this well, and that really improves its water recharging capacity. But in the case of the kacha well, these are very temporary wells, and they are having very shallow depth, and they can be constructed by cultivators or by any irrigation suppliers in the field. You might have heard of this kacha wells. It doesn't have a very longer duration of life. Next, we can also calculate the yield of, or what is the volume of water that is extracted from the open well. So for that we have got two methods. One is the pumping test method, and such as the equilibrium pumping test, and other is the recuperation test. So we have seen the recuperation test in our previous slide. So here we are going to just quickly go through what is the pumping test and how we can just calculate the yield of the well by using this pumping test. So we have given so in this case also, pumping equilibrium pumping test, what actually we do, that we just try to extract the water from the well. Okay, so when we do so, the water that we extract from the well, there will be a drawdown effect, and due to which the water will again just get recharged in this well, and it will come to a constant height. So there would be a certain rate at which when we just extract the water and the water recharging capacity, both will be equal. In that condition, when you just take out water, the water level will be constant. So that is the condition of the equilibrium. In that case, we are going to use the again Darcy's equation. We are going to use this Darcy equation that we have seen, the Dupit's formula. We are going to use the drawdown and various these values, and then we will do a integration method, and then we will try to, and then we will obtain the discharge, that is Q is equal to CS, and by using this equation we can just calculate the discharge of certain types of the well. Next is this recuperation test that we have again seen from in our previous slide. What is the recuperation test? In this we just take out the water from this well, and when it goes down again, the water gets filled in it and gets recharged, and it goes again back to its normal position. So it takes time to go up to that static water level. So we just note down the what is the time, what is actually the time taken by that water to come back to that normal level. So these are again the various denotation that we have used here. We will again use this equation, and we will calculate the, by using the integration method, we will calculate the what is the discharge in this shallow well, which we have done in our previous slide, and from there we will calculate the discharge of this shallow type well, which is Q is equal to C dash over A into AS, and this value will be given in the question. You just need to put that value, and then you can get the discharge value of such type of the shallow well. So let us understand this by a simple example in which it is given to design an open well. Design an open means we have to find the diameter if you want. So if we find the diameter, that is the design part of the open well, and it is given that the yield is 0.004 cubic, and that is being operated at a depression head of 3 meter. So we're just going to convert this into the cubic meter per hour. Its value will be given in the question. The depression head is given, just put all those value over here, you will get the value of area, and by using pi by 4 d square you will get the value of the d. So let us suppose that it is 2.5 meter. So by this way we can just design an open well. Okay, so in the next tutorial video we will just go through the tube wells and its various type, and how we can just construct the tube wells in order to extract the groundwater. Okay, thank you.